The other question in 2003, and it was question number 4. It reads the probability that it rains on Monday, that's 1/3. The probability that the teacher will be present on that day when it rains, that's 1/6. And the probability that the teacher will be present when it does not rain, that's 7/10. Draw a tree diagram and label. Add the probability for all the branches. So our solution here, our first branch. So we have rain as represented by R, no rain as N. So when it rains, that's 1/3. That's 1/3 when it rains. So in the previous video, sum of all probabilities of an event, the answer is 1. So no rain and rain, answer should be 1. The no rain we don't know, plus 1/3, that's the probability of raining there, and here the answer is 1. So what we need to do is the other side. So n is equal to 1/1 minus 1/3, and the common denominator, that's 3. 1 into 3, that's 3. 3 times 1, that's 3, minus 1 3 3, that's 1. 1 times 1, that's 1. And the probability of not raining here, the answer is 2/3. So no rain here, that's 2/3. Now next thing, from the question, and now the probability that the teacher will be present on that day when it rains. So we are going to have another branch here. So we have present and the absent. So P for present, A for absent. So the teacher will be present, its probability, that's 1/6. So here it's 1/6. So we must add 5, so that it should be 6/6. We're supposed to add 5, 6/6. So here the remaining one, so probability of absenteeism there, that other one, it's 5/6. And then and the probability that the teacher will be present when it does not rain, the same applies here. We have present and absent. Absent, they are present. So when it does not rain, the presence of the teacher, that's 7/10. So here we have 7/10 there. So 7/10, we must add the 3 to 7 here, put it carry 10/10. They would have, it should be 3/10. From the branches, if we add this guy and this guy in that pair, it gets 1. The same applies here, it gets 1. So that's it about this question. And the marks are very, and this is I think it's fair, 6 marks. But anyway, that's it. Mind you, if you're enjoying this video, don't forget to subscribe to my channel. You can also like my page on Facebook, Unique Online Classes as well. And you can replay the video. You can reach me on this number 0882 435 562. So let's now move to another question. Question number 10, I don't live in. In his village, families are allowed to keep 3 types of animals: chickens, goats, and pigs. The probability that the family will keep a chicken, a goat, and a pig, and 1/2, 1/5, and 1/10 respectively. Draw a tree diagram to illustrate this information. We should calculate the probability that the family will keep only one type of animal. So so our tree diagram here, branch if, that's our branch there. And then in the chicken, no chicken. So N as no chicken, complete no chicken there. That's the first thing. So for chicken, it's 1/2. So here I'm putting 1/2. The good no chicken is a cancel 1/2. That's the thing. We are done with that. So goat for magamba respectively. The good for goat, that's 1/5. So here ngati akupanga nkhuku ndikuti athanso kukhala ndi yani athanso kukhala ndi goats. So we have goats and no goats, no goat. So for goats that's 1/5, 1/5, uku ndikuti zakhala 4/5. So that if we add 1/5 ndi 4/5 answer dzatipatsa 1. The same applies here, chifukwa zitha kutheka kuti mulimiyo sakukhala ndi chicken komano ndikumakhala ndi nkhuku, ndikumakhala ndi goats. So we have goats and no goat. So we're going to repeat the same steps, 1/5 and 4/5. That's the thing. And we have this one for pigs, and then it comes to the branching of pigs, the no pigs. So for pigs that's 1/10. So no pigs is a 9/10. So if you add 1/10 and 9/10 answer that's 1. And it is going to cancel the same steps, pigs, no pigs, which is 1/10 over 9/10. Also and we have pig over no pig, which is 1/10 versus 9/10. Yeah, that's 10 there. And this one as well, pig and no pig, which is 1/10 versus 9/10. So our probability space, we have chicken, goat, pig, and we have this one, chicken, goat, no pig. So we have chicken, goat, the no pig. We are done with that one. Commercial in the chicken, no goat, pig. So we have chicken, no goat, pig. Kakipeka kinkamineko ndeti bwalanso inayi iyi ndekuti ndi chicken, no goat, no pig. We have chicken, so should like see chicken, no goat and no pig. And here we have no chicken, goat, pig. So we can get a path here, and this part here is a no chicken, goat, no pig, no chicken, goat, no pig. And this root as well is a no chicken, no goat and pig. This one, this one, this one, and this one. And the only is no chicken, no goat, and no pig. So tapanga ife taionetsa pachani a tree diagram according to the first part of the question. And now what is the probability a family will keep only one type. This one should be one type of animal. So one type of animal, we're going to take this one, it's only chicken. So we're going to take this one, it's only goat. So we're going to take this one, it's only pig. So if we follow this path, which is 1/2 times 4/5 times 1/10. That's the first part. And also this guy, and this guy representing here, which is 1/2 times 1/5 times 1/10. times 9 over 10. Here that's 9 over 10. Ndekuti so part imene itathana nayo. And then yomwe ikutsala it's this one. Ndekuti chimene tipange tizatenga uyu komanso tidzatenga uyu. So pamene kuti ndi 1 over 2 times 4 over 5 times 9 over 10. So we have to add the products of these. So maybe ipangire 119. So that's 9 over, I think I should choose a blue pen. 9 over 5 times 10, that's 50 times 2, that's 100. Ndekuti pati ndimene answer yake. And then tikabwera apa 2 mu 4 akulowa ka 2. Ndekuti 2 times 1 times 1, that's 2. And 5 times 10, that's 50. So this part we have this guy, as well as here 2 kalowa mu 4, that's 2. And 2 times 9, that's 18. 18, 5 times 50, 5 times 10, that's 50. And if you can simplify this one, 2 more 18, that's 9. And 2 more 50, that's 25. So that's another part. Then we made bange, we're going to add uyu. Could P only one, yeah, only one animal, equal 9 over 25 plus 2 over 50 plus 9 over 100. 9 over 100. So our common denominator here, that's 100. That's 4. 4 times 9, that's 36. Plus we call 2 times 2, that's 4. Plus we call that's 1 times 2, that's 9. And if we combine 36 in the 4, that's 40. In the 9, that's 49 here over 100. So our answer is this one. And then the other question, a bag contains beans, groundnuts, and maize seeds. The probability of getting at random a bean seed, that's 1.5. 1 over 5. And for groundnut seed, that's x over 15. Whereas of maize seed, that's 1 over 3. And you should find the value of x. We should find the value of x. So our solution, mubagi mumuli zinthu zitatu mtedza chimanga ndi nyemba. Mind you, these are the probabilities. And for a certainty, P beans plus P maize plus P G groundnuts, I said that's 1. So we have 1 over 5, that's for beans, plus for groundnuts, for maize, maize at 1 over 3, and for groundnuts, that's 1 over 15, as I should be 1 here, and sorry, here should be x. Here we have x over 15 as given above. So common denominator, that's 15. 5 into 15, that's 3. 3 times 1, that's 3. Plus 3 into 15, that's 5. 5 times 1, that's 5. Plus 15 into 15, that's 1. 1 times x, that's x is equal to 1 there. And if we add like terms together, we're gonna have 8 plus x over 15 is equal to 1. So I should write 1 over 1. Could cross multiplication with the prayer. So if we multiply these, that's 8 plus x, and if we multiply 15 and 1, that's 15. So value of x equals 15 minus 8 the x is equal to 7. So that's the thing. When we have been awarded total marks 15. That's it. Yeah. Let's now move on to another question. This question, it was question number 4 in 2007. That's about experimental probability. It reads 2 fair dice, each of 6 faces, numbered from 0 to 5 and loaded at the same time. Table 1 shows the possible sums of the number on the dices. So that's the table. Calculate the probability of getting a sum of less than 4 in a sum which is multiple of 5. So you can see this side could dice in, also could dice in. So my side is 6 on the minimum. Ndechi meju machitika ma values amene ali nkaliwa amaphatikiza yauku ndi yauku kudzatipatsa uyu. So zakuti 2 ndi 4 ali apa watipatsa amene 3 ndi 4 ali apa watipatsa 7. Chimodzimodzi 4 ali apa ndi 2 ali apa mudzaona kuti watipatsa 6 apa, and 5 ali apa ndi 3 apa muona watipatsa 8. So according to the question zimene akutanthauza kuti sums of numbers on the dice. So that's the thing. Now we should calculate the probability of getting a sum of less than 4. The thing going on is less than 4. So if you can see here, 4 that's 4. So zimezi less than 4. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ndekuti this part solution yake chimene tipanga p less than 4, p angonera less than 4 saneko equal to akanena kuti equal to ndikuti tikanapanganso include awo. So we only focus on that less than is equal to sum which is less than 4, sum which is less than 4, kamina number of numbers which are less than 4, numbers less than 4, that's less than 4 over total sums, total sum numbers. Ndi chimiti pange tawerengezo kuti zilipo 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And then total zilipo zingati. Tikabwera this side 1, 2, 3, 4, 5, 6. This side 1, 2, 3, 4, 5, 6. So that's a 36. 6 times 6. Here is 36. And you see, if we simplify that one, tingotenga 2 mu 10, that's 5, and 2 mu 36, that's 18. So this is the answer here about sum which is less than 10. And sum which is multiple of 5. Multiple of 5, I don't know what 5 are. So multiple of 5, we have this one 1, 2, 3, 4, 5, 6, so 7, 10. It's a multiple of 5. So we have 1, 2, 3, 4, 5, 6, 7. So it's made bang multiples of 5. Our solution of this guy, p multiples of 5, multiples of 5 is equal to numbers kutalipa ngati which are multiples of 5. So that's 7, and total numbers here is going to 36. We're going to put 36 here. So yeah, marks are already 3 marks for this one, 4 marks for that one. As simple as it is. But please don't forget to subscribe my channel if you are enjoying this video. Kumaso ngati muli kufuna kwabwino and you'd like to sponsor me, you can contact my number 882-435-562. Mutandoza kuti you want to sponsor me. Kumaso ngakhawi you are in holidays mutanso ndipanga haya so that I should help you physically. So we provide by the time classes. So let's now move forward to another question. The other question, which is the last one in this video, the question number 6. Imene afunsidwa 2008. Amuna kuti The probability of a bus arriving early at a depot is 1/10. Arriving early, that's 3/5. That would if 400 buses are expected at the depot during the day. Sorry, calculate the number of buses that are likely to arrive at the depot. So tumedipange solution. I think ababa we can solve this one in two ways. So the first way, we're going to add all probabilities to that's one. So we have those that are arriving early, so early plus arriving late, and we have those which arrive in time. So in time, that's I, arrive in time. So some of these probabilities are set that's 1. So arriving early at that's according to 1/10 plus arriving late at that's according to 3/5 at that's according to 3/5, and the arriving in time we don't know, so that's 1 here. And if we move these ones, could is bit of it's and the I is equal to 1/1 minus 1/10 minus 3/5. Our common denominator here, that's 10. 1 into 10, that's 10. 10 times 1, that's 10. Minus 10 into 10, that's 1. 1 times 1, that's 1. Minus 5 into 10, that's 2. 2 into 2 multiplied by 3, that's 6. So I there, I here is equal to 10 minus 1, that's 9. And 9 minus 6, that's 3/10. So this is the probability of buses arriving in time. So to find the number, we are going to multiply number of buses arriving in time. So in time here is equal to 3/10 times total number of buses which are expected to arrive, which is 400 here. So we're going to multiply here by 400. So 10 into 400, that's 40. 3 times 40, that's 120. So these are the buses which were supposed to arrive at the depot in time. So that's the first step. I mean, not the first step. Or else you can follow this way. Just add the given probabilities. Add. So if you add that one, if you add 1/10 plus 3/5, our common denominator here, that's 10. 10 into 10, that's 1. 1 times 1, that's 1 plus 2, that's 2. 2 times 3, that's 6. And our answer here, that's 7/10. So this is the sum of the probabilities of vehicles arriving late and early. So we have to find the. So it's 7/10 times 400 here. 10 into 400, that's 40. And 40 times 7, that's should be 280. That's 280 vehicles. 280 vehicles which were 280 buses. So this one says buses amenafika late komanso on time, late komanso on time. Mabasi age analipo not on time, but it should be early, late and early. So total it's 400. We're supposed to subtract here 280. If you subtract, answer it's 120. So the remaining ones which will arrive in time in the 120. So that's another formula. You can solve it in that way. That's it for this video. Thanks for watching, and have a lovely day. But please don't forget to subscribe my channel. And if there is any question, you can ask me using the number I've indicated in the video. And if you want to sponsor me as well, you can do the same. And your support will be greatly appreciated. So that's it for this video. Thanks for watching and have a nice prep always. Wish you all the best.